This example comes out of section 1.3, one-sided limits. So we're given another one of these piecewise functions. We're told f of x equals negative x plus 7 if x is less than or equal to minus 1. F of x equals x squared if x is between negative 1 and 1. And then f of x equals 3x minus 2 if x is greater than 1. And then we're asked to determine whether or not the limits are existing at these important or interesting points when x is minus 1 and x is positive 1. The rest of the time the limit will exist because all of these by themselves would be continuous, easy to define functions. But if we look at this thing and we have between negative 1 and positive 1, we have ourselves a parabola, y equals x squared between there. At negative 1, we actually have negative x plus 7, so this strange linear function that is actually quite a bit higher. 2, 3, 4, 5, 6, 7, 8, 1 plus 7 is 8, and we have a line looking something like that heading off to the left. And then 3x minus 2, if I put in 1 there, 3 times 1 is 3, minus 2 is 1, and it actually comes and it does meet this point here, and it has a slope of 3 up 3 over 1, and we have ourselves a graph that heads off like this. And so the question about the limits, once you have the graph, is quite a bit simpler, because if I look at the limit as x approaches negative 1 from the left, the answer here is as I approach from the left towards x equals negative 1, the answer is 8. As I approach x equals negative 1 from the right, I just have the parabola piece of this function, and the answer is 1. Negative 1 squared is 1. And so the limit as x approaches negative 1 of f of x, the two-sided limit, does not exist. You can't have an answer to that. So definitely this graph is not continuous at x equals negative 1 either, because while the function equals 8, the limit does not exist. Now, looking at the other side of this, the limit as x approaches 1 from the left, as I follow along the parabola towards 1, the answer is equal to 1. The limit as x approaches 1 from the right of this function, as I follow down this steeper straight line towards 1, it actually gives me an answer of 1 as well. So the two-sided limit here does exist, and it actually equals 1, since the left side and right side limit both equal 1. It's also true that f of 1 equals 1. So this graph is continuous at 1. Is continuous at x equals 1, not continuous at x equals negative 1. And that question could be answered just by looking at the graph as well. But that definition of continuity is somewhat important as we go along.